So this time, we will talk about the local linear approximation and differential approximations. So, application pa rin ito ng derivatives. This chapter class, you will be able to learn how to calculate derivatives. We use them to solve problems involving rates of change and the approximation of functions. In this module, we will tackle about the linear approximations, the approximation using differentials, the differential notations, and the derivative as a rate of change. In this section, we are going to take a look at an application not of derivatives, but of the tangent line to a function. Since to find the tangent line, we do need to take the derivatives. So in some way, this is also an application of, this is also an application of derivatives. So we have seen that the curve lies very close to its tangent line near the point of tangent C. So in fact, by zooming in toward a point on the graph of a differentiable function, we notice that the graph looks more and more like its tangent line. The observation or this observation is the basis for a method of finding approximate values of functions. So actually class, itong graph na ito is na-discuss ko na to. Yung tangent line is na-discuss ko na doon sa geometric interpretation of derivative yung sa previous module ata, if I'm not mistaken is sa prelim or sa midterm na first topic. The idea is that it might be easy to calculate a value f of a function, but difficult or even impossible to compute nearby values of f. So we settle for the easily computed values of the linear function L, whose graph is the tangent line of f at the point A and f of A. So in this figure, etong pink na line, yan yung linear function L natin, which is yung graph niya is tangent to this function na y equals to f of x at this point. So eto yung point of tangency nila sa point na A and f of A. In other words, we use the tangent line at the point A and f of A as an approximation to the curve y equals to f of x when x is near at A. So an equation of this tangent line class is y equals to f of A plus f prime of A times x minus A. So ito yung equation ng tangent line natin sa approximation to the curve y equals to f of x. And the approximation f of x is approximately or equivalent to f of a plus f prime of a times x minus a. Okay, so ito yung approximation niya. Ito yung equation of the tangent line, and then this is the approximation f of x, or yan yung function natin, or yan yung curve natin na y equals to f of x is approximately equal to f of a plus f prime of a times x minus a. So this we consider this one as our equation 1, and this is what we call the linear approximation or the tangent line approximation. So remember this formula kasi magagamit natin ito sa next slide para doon sa example natin. So this is the linear approximation or tangent line approximation equation of f at a. The linear function whose graph is this tangent line, that is, okay, yung linear function naman natin na L na tangent siya doon sa curve natin na y equals to f of x at the point A and f of A, is ito din yung formula niya. L of x is equal to f of A plus f prime of A times x minus a. So actually, parehas lang, diba? Equal lang sila. Equivalent lang sila. So this is what we call the linearization. Kung linearization, ibig sabihin L of x yung formula natin. Kung linear approximation or tangent line approximation, ganito yung makikita ninyo na symbol. For example, find the linearization of the function f of x equals to the square root of x plus 3. So, ito yung given natin na function or curve. Hahanapin natin yung linearization ng function na to at a equals to 1 and used it to approximate the numbers square root of 3.98 and square root of 4.05. Are these approximations overestimates or underestimates? Okay, so let's see if these numbers overestimates or underestimates ba yung approximation nila. So, to solve that one or to find the linearization of the given function, first is kailangan natin kunin yung derivative nito or i-differentiate natin yung given na function. So, the derivative of the function f of x equals to x plus 3 raised to 1/2. So, ito class, ito yung exponential form ng given natin na function. Ito. Okay. So, di ba yun yung na-mention ko doon sa pag-derive, kapag naka-radical yung expression natin, express it first into exponential form before nyo siya i-derive or i-differentiate. So, the derivative of this function class is magiging f prime of x equals to 1/2. Bring down lang si 1/2 times x plus 1 to the power of negative 1/2. Because 1/2 minus 1 is negative 1/2 times yung derivative ni x plus 3 na 1 lang man, diba? Because derivative ni x is 1 and then derivative ni 3 is 0. So, 1 plus 0 is 0. 1 lang man. So, times natin sa x plus 3 times 1/2 is still pa rin na ito yung result. Or this is just equal to 1 over 2 square root of x plus 3. So, nilagay natin sa denominator ito para maging positive yung exponent siya. So, we have, kung i-substitute natin yung value ni a equals to 1 dito sa na-derive na function, what I mean is, sa na-derive na function at saka sa given na function, kung sa i-substitute natin yung a equals to 1 sa given na function, ang makukuha natin na f of 1 equals to 2. So, magiging f of 1 replace x by 1, so magiging square root of 1 plus 3 is the square root of 4. The square root of 4 is 2. Ito yung given natin na function. And then, substitute din natin sa na-derive na function. So, f prime of 1 is equal to 1 over 2 times the square root of 1 plus 3 or 1 over 2 square root of 4. So, i-simplify natin plus. We have 1/4. So, ito yung value ni f prime of 1, which is, ito siya, magagamit natin sa formula ng linearization. So, putting these values into equation 2, yung formula ni linearization, we see that the linearization class is L of x equals to f of 1, where 1 is yan yung a natin sa formula, diba? Sa formula 2 sa previous slide. And then, plus f prime of a or f prime of 1 times x minus 1 or x minus a. Kasi ang given na a is equal to 1. So, ang value na nakuha natin sa f of 1 dito, sa pag-substitute natin doon sa original na function is 2. So, that's why 2 ito. And then, yung value din ni f prime of 1, pag after natin i-substitute sa na-differentiate na function, ang nakuha na result is 1/4. So, that's why 1/4. And then, just copy x minus 1. So, simplifying natin. So, 2 plus 1/4 times x minus 1. So, we have 7 over 4 plus x over 4. Okay, so distribute muna si 1/4 dito and then saka natin siya i-add. So, the corresponding linear approximation in equation 1 is, okay, kung linear approximation, yung sabi ko nga, makikita niyo yung symbol na yan. Okay, so f of x is approximately equal to f of a plus f prime of a times x minus a, or simply, palitan natin si f of x, ang given na f of x is the square root of x plus 3, yan yung given natin na function, diba? And then, yung equivalent ni f of a plus f prime of a times x minus a at a equals to 1 is 7 over 4 plus x over 4. Galing siya dito sa linearization. Okay, when x is near 1. So, in particular class, we have, so after daw yun, gamitin natin yung linearization, yung result ng linearization na yun sa numbers na square root of 3.98 at saka 4.01. So, tingnan natin if yung approximation ba natin dito is mag-overestimate ba siya or underestimate. Kung sa square root of 3.98, we have, eto class, eto lang yung ginamit na formula ha. Etong part na to. Okay, si square root of x plus 3, pinalitan siya ng square root of 3.98. Galing doon sa given natin. Kasi yan man yung isa sa pinapahanap. Is approximately, so bring down lang natin dito. Kaya ito class naging 0.98. Diba x yan? Tapos x din yung given dito. Ano yung number na mag-a-add or ano yung value ni x na ilalagay natin dito para maging 3.98 siya? Diba? If we let x is equal to 0.98 plus 3, that is equal to 3.98. So, ibig sabihin, equivalent lang din ito. Ang value ng x natin dito class is 0.98 or this is equal to 1.995. Kung square root of 4.05 naman, the same pa rin yung gagamitin natin ng formula. Ano yung value ni x na mag-a-add kay 3 para maging 4.05. So, di ba ang value ni x na mag-a-add kay 3 para maging 4.05 is 1.05. So, that's why yung x natin dito class is napalitan siya na 1.05. So, that is equal to 2.0126. The linear approximation is illustrated in figure 2. Okay. This is the figure 2. So, etong pink na line, yan yung graph ni y equals to 7 over 4 plus x over 4. So, pag-solve natin sa linearization, ito yung nakuha natin na linear graph natin. And then, yung blue na yan yung given natin na curve na square root of x plus 3. So, ito yung point of tangency nila, 1, 2. So, we see that indeed, the tangent line approximation is a good approximation to the given function when x is near 1. So, tama, di ba? Kasi yung linear graph natin is, pag malapit siya sa 1, dumikit siya doon sa tangent line natin na y, o sa curve natin na y equals to the square root of x plus 3. We also see that our approximations are overestimates because the tangent line lies above the curve. So, ibig sabihin nun, if yung tangent line natin is lies above the curve, etong pink line na yan, or yung linear graph natin class is, it lies above the curve, etong curve na blue. Ibig sabihin nun, yung approximation natin are overestimates. Kung lies above or below the curve naman, that is underestimates. Okay, so that is for the example 1. So the next topic is the approximation using the differentials. Kanina kasi is linearization or local linear approximation. The approximation using differential class. In this section, we are going to introduce a notation that we'll be seeing quite a bit in the next chapter. So we will also look at an application of this new notation. So let us consider the equation y equals to f of x, where f is a function. In many applications, the independent variable x is subjected to a small change, and it is necessary to find the corresponding change in the dependent variable y. Kung ito yung equation natin class, si variable x dito class, ito yung independent variable natin. And then si y naman is the dependent variable kasi magdidepende yung value niya kay x. Okay. If x changes from x sub 1 to x sub 2, then the amount of change is often denoted by the symbol delta x. Okay, this is read as delta x. nakita ninyong parang may triangle and then the variable, that is, it is read as delta x rather. That is, delta x is equal to x sub 2 minus x sub 1. Ibig sabihin ng delta x na yan is a change from x sub 1 to x sub 2, or kumbaga sa distance na kakwa sa distance na x sub 2 minus x sub 1. Distance 2 minus the distance 1. Okay. So the number delta x is called the increment of x. So ang tawag dito is increment of x. Similarly, delta y denotes the change in the dependent variable y, which corresponds to the change delta x. So thus, delta y is f of x sub 2 minus f of x sub 1, which is equal to f of x sub 1 plus delta x minus f of x sub 1. So, ito yung tatandaan natin na formulas dito. Si delta y at saka si delta x. Madali lang yung kay delta x kasi x sub 2 minus x sub 1. 0.2 to minus 0.1. Yung kay delta y naman, for increment of y, is yung function na f of x sub 2 minus the f of x sub 1, or f of x sub 1 plus delta x. Okay, kaya ito naging x sub 1 plus delta x. Okay, using this equation. Okay, solving for x sub 2 lang. So, equivalent lang sila, class. Tapos, f of x sub 1. So, let's give an example para maintindihan natin yung approximation using differentials. If y equals to 3x squared minus 5, find the change delta y if the initial value of x. Okay, so ito yung hahanapin natin, si delta y. Ang given is the initial value of x. Ibig sabihin, x sub 1 natin is equal to 2, and then delta x natin is equal to 0.1. Okay, so yan yung given natin. To find delta y, class, we use this formula. Yung nabanggit sa previous slide, delta y is equal to f of x minus f of x sub 2 minus f of x sub 1, or pwede din ito yung gamitin natin, f of x sub 1 plus delta x minus f of x sub 1. So formula lang talaga yung dito sa approximation using differentials. So we need to solve for the value of f of x sub 2 para dito, and also the value of f of x sub 1 para din dito, para ma-obtain natin yung result ni delta y. By substituting our given values to the given function, y equals to f of x. Okay, ito yung given natin na function, 3x squared minus 5. Okay, f of x sub 1 is equal to f of 2. Bakit ito naging 2? Kasi diba ang given natin na initial value, sabi niya dito initial value of x, or that is x sub 1. That is equal to 2. So that's why f of x sub 1 natin is equal to f of 2. Kung nakalagay dito, classes, initial value of x is 3, of course 3 din yung ilalagay niyo dito sa f of x sub 1, or i-replace niyo kay x sub 1 is 3. Okay, and then substitute lang natin sa given natin na function. So we have 3 times, okay, replace x by 2. So 3 times 2 quantity squared minus 5, which is equal to 7. So ito yung value ni f of x sub 1. So okay na tayo dito. How about the f of x sub 2? To solve for f of x sub 2, class, we need to find first the value of x sub 2. Using this formula, so we get delta x equals to x sub 2 minus x sub 1 is equivalently equal to, okay, given din yung delta x natin, okay, which is equal to 0.1. Ito siya, okay, and then si x sub 2, yan yung hinahanap natin. So ito siya, class, and then si x sub 1, given din si x sub 1, that is equal to 2. So that's why naging minus 2 ito. So solving for the value of x sub 2, we have x sub 2 is equal to 0.1. Transpose natin si 2 sa left side. So 0.1 plus 2 is 2.1. So ito yung value ni x sub 2. So after that, pwede na nating ma-solve si f of x sub 2. pag f of x sub 2 nakalagay dito class, doon nyo, yung value ni x sub 2, doon nyo isa-substitute sa original na function. Okay, so solving for f of x sub 2, we have replace x sub 2 by 2.1. Okay, so replace natin si x dito by 2.1. So 3 times 2.1 quantity squared minus 5, which is equal to 8.3. Thus, pwede na natin ma-solve si delta y. So delta y is equal to f of x sub 2 minus f of x sub 1. Ang value ni f of x sub 2 is 8.3 from here. And then, minus f of x sub 1, ang value niya is 7 from here also. That is equal to 1.23. So therefore, the change delta y is equal to 1.23. The increment notation may be used in the definition of the derivative of a function. All that is necessary is to substitute delta x for h in the definition of derivative and regard x as the initial value of the independent variable. Thus, f prime of x is equal to the limit of f of x plus delta x minus f of x divided by delta x as delta x approaches 0. So, diba, ito yung definition ng derivative. Yung sa first, before tayo nag-discuss ng theorems on differentiation, yung three-step rule. So, ito siya. Ito yung definition ng derivative. Ni-replace lang si h ng delta x. Kasi ang sabi mo niya dito, all that is necessary to substitute delta x for h. Nalitan si si h ng delta x. Yan, sa denominator and also ito. So, using delta y equals to f of x plus 1 plus delta x minus f of x sub 1 with x as an initial value. Then, the delta y is equal to this. And we have the first derivative or f prime of x is equal to the limit of delta y. So, ibig sabihin, nagiya numerator tano, naginan buso delta y tano. Miya mention niya ro sa previous slide class. And then, just copy delta x sa denominator. So, in words, pagkabasa nito class, the derivative of f is the limit of the ratio of the increment delta y of the dependent variable to the increment delta x of the independent variable as delta x approaches 0. Okay, so note that if x is equal to x sub 1, then delta y divided by delta x is approximately equivalent to f prime of x if delta x is equivalent to or approximately equal to 0. So geometrically, if delta x is close to 0, then the slope delta y over delta x of the second line through 2 points, say P and Q, is close to the slope f prime of x of the tangent line at P. So when we also write delta y, okay, we can also write delta y approximately f prime of x times delta x if delta x is approximately equals to 0. We give the expression definition f prime of x delta x as a special name in the next definition. So in definition 5.3, if the function f defined by y equals to f of x, then the differential of y denoted by dy is given by dy equals to f prime of x times delta x. So, ibig sabihin class, yung dy na yan is equal lang kay increment of independent variable of dependent variable delta, the dependent variable y rather, or the delta y, where x is the domain of f prime and delta x is an arbitrary increment of x. Another definition is if the function f defined by y equals to f of x, then the differential of x denoted by dx, okay, dx na yan, ibig sabihin yan differential of x, dy differential of y, is given by dx equals to delta x, where x is in the domain of f prime and delta x is an arbitrary increment of x. So, kailangan familiarize din natin to. dy is equal to f prime of x times delta x. Si dx naman or differential of x is equals to delta x lang. If y equals to f of x and f prime of x exists, then dy equals to f prime of x dx. Okay, so let's give an example. First example is if y equals to 3x squared minus 5, the same with the previous example. Use dy to approximate delta y. Okay, if x changes from 2 to 2.1. Okay, so from example 5.2 class, ang delta y natin doon is 1.23 yung na-obtain natin, diba? Okay, so using dy equals to f prime of x dx, ito yung formula sa previous slide na yung sa definition 5.4. So, ang derivative nito class is 6x, diba? 3 times 2 is 6. X to the power of 2 minus 1 is x na lang, minus 0 man. So, pag ginamit ninyo is etong differential notation na to, f prime of x dx, pag nag-derive kayo, ilalagay ninyo yung dx sa class. Kumbaga na, sa Gaya formula, na kinuha buso derivative yan, tapos si dx na inisurat buonan or cubed yan. Okay, Gaya na, derivative ya puon si isabya function tano. Since ang x natin is equal to 2, and then delta x natin is equal to dx man, diba? Which is, ang delta x is x sub 2 minus x sub 1 man. So, ang x sub 2 natin dito is 2.1. Kasi changes from 2 to 2.1 man. From x sub 1 to x sub 2. Okay. 2.1 minus 2, which is equal to 0.1. So, ang dy natin class is magiging 6 times 2, okay, times 0.1. Okay, so ang x natin equals to 2, galing dito. And then, yung dx natin, ni-replace siya. Okay, yung dx, ni-replace by 0.1 from here because delta x is just equal to dx. So, which gives us the correct approximation after the nearest 10. Okay, so that is equal to 1.2 yung result ni dy. If ang given natin na function is 3x squared minus 5, and if x changes from 2 to 2.1. Another example, if y equals to x to the power of 4 minus 3x squared plus 5x plus 4, first is find dy, and then the value of dy if x equals to 2 and dx equals to negative 0.5. So, sa dy, madali lang. Derive lang natin yung given na function. Okay, so ang derivative ni x to the 4 minus 3x squared plus 5x plus 4 is 4x cubed minus 6x plus 5. And then, derivative of 4 is 0 naman. And then, si dx, yan, given talaga yan. Pag nag-derive kayo with respect to x, kailangan may dx dito. Okay, kumbaga na, Gaya f prime of x, nag-Gaya si derivative of function na, si dx na, kapiyabuanan. And then, dy, so number 2, the value of dy is, ano daw yung value ni dy if yung x natin is equal to 2 and dx natin is negative 0.1. Okay, so since si dy is 4x cubed minus 6x plus 5, okay, eto siya, diba, yung sa solution natin sa result natin sa first dito, sa number 1. Since x is equal to 2 and dx is negative 0.1, so we have substitute natin dito. So, di ba ito yung formula? Okay. So, ibig sabihin nun na sa Gaya, may derived na function na sambihan na buwaya. Si x nasambihan sa 2, si x nasambihan sa 2 man. Okay. So, that is equal to negative. And then, si dx, nasambihan sa niyang busa, negative 0.1. Substitution lang to class. So, dy is equal to negative 2.1. 5. So do not worry, formula lang and then substitution. So in this example, use the differential to compute the fifth root of 33 approximately. To work this problem class, we need an idea. So it is simply that we know the fifth root of 32 is 32 exactly, and 33 is close to 32, diba? Kasi alam natin na yung fifth root of 32 is 2. 2 to the power of 5 is 32, diba? So, since si 33 na close siya kay 32, kailangan natin yung idea na yun. So, the function we are talking about is f of x is equal to the fifth root of x, which is equal to x raised to the power of 1 over 5. So, kailangan natin yung function na to. Okay? Si x is hindi pa natin alam kung ano yan. If we think of x is equal to 32 and delta x is equal to 1, then f of x is equal to f of 33 is what we need, is what we want to find. So we know that delta y is equal to f of x plus delta x minus f of x, which is ang x natin dito, if we think of x as 32 ha, kasi yan yung perfect square, perfect fifth root na alam natin, di ba? Na malapit kay 33. Hindi rin pwede na 34 kasi hindi naman siya perfect fifth root. Right? Hindi rin pwedeng 36 kasi si 36 is perfect square man yun. 6 to the power 2. So si 32 lang talaga yung malapit kay 33 na pwedeng makuha natin yung exact amount value niya. So, replace x by 32 plus 1. So, ang delta x natin dito is equal to 1. Okay. Tapos, minus f of 32. So, since 32 plus 1 is 33, f of 33 minus f of 32 rather. So, while yung dy natin class is f prime of x times the delta x. So, ang delta x natin class is equal to 1. Kasi nga, di ba, ang delta x, ang formula niyan is x sub 2 minus x sub 1. Ang x sub 2 natin is 33 minus x sub 1 na si 32. 33 minus 31. 33 minus 32 is equal to 1. So, that's why naging 1 yung delta x natin. 33, yan yung given natin. Minus, yan yung alam natin na number na makukuha natin yung exact value niya. Okay, 32. 33 minus 32 is equal to 1. X sub 2 minus x sub 1. So, kunin natin yung derivative na to. So, dy equals to f prime of x times delta x. So, f prime of 32 times 1. So, kunin natin yung derivative ni f prime of x and then substitute natin si 32. Okay, so the derivative of f class, derive natin to, that is 1 over 5, x to the power of negative 4 over 5, or pwede rin na 1 over 5 times this, yung tawag dito, the fifth root of x to the power of 4. Okay, and substitute natin si 32 sa derivative na to, sa function na to rather. So, f of 32 is equal to 1 over 5, replace x by 32. So, this is equal to 1 over 5. Bring down natin ito sa baba para maging positive yung exponent niya. So, we have 1 over the fifth root of 32 raised to 4. Or, ang result nito is 1 over 16. So, 1 over 5 times 1 over 16 is 1 over 80. So, ito yung f prime of 32 natin, 1 over 80. Ang dy naman natin class is, di ba ang nakuha natin na value ni f prime of 32 is 1 over 80. So, replace natin si f prime of 32 by 1 over 80. And then, just bring down 1. So, 1 over 80 times 1 is 1 over 80. So, parehas lang. So, si f prime of 32 is equal to dy. Using the fact that df is almost the same as dy. Okay. We write f prime of 33 rather. Kasi di ba ito yung given natin na number. Okay. Is equal equal to f of 32 plus delta y is approximately f of 32 plus dy. So, ang f of 32 natin plus delta y is approximately f of 32 plus dy. So, therefore, the fifth root of 32 plus, okay, the fifth root of 32 is equal to f of 33, approximately 2 plus 1 over 80. Saan ang galing si 2? Yan yung value ni f of 32. Plus yung 1 over 80 is yan yung value ni dy. So, which is equal to 2.0125 approximately. So, the actual error in this computation is less than 1 over 6,400. 1 over 6,400. The next example illustrates that the differentials may be sometimes used to estimate errors. So if there is an error in the measurement of a quantity, we define average error is equal to error in measurement divided by measured value. This is called the relative error. And the percentage error naman class is the average error multiplied by 100. So, relative error yung walang 100, walang naka-times na 100, or hindi pa na-multiplied into 100. Kung na-multiplied na siya by 100 class, that is the percentage error. So, for example, if the measured length of an object is 25 inches with a possible error of 0.1 inches. Okay, so ito yung error niya. Then, the relative error is 0.1 divided by 25. Kasi diba ang formula ng average error natin, or the relative average error, is error in measurement. So, ang error dito is 0.11 divided by yung measured value natin na 25 inches. So, that is equal to 0.004 inches per inch. And the percentage error is yung eto, i-times lang natin siya ng 100%. So, that is equal to 1. So, this is the, 1 is the percentage error, then 0.004 is the relative error. Suppose that f is a function and we wish to find the f of a. The value a to be determined by measurement. This measurement is not precise. Measurements never are, diba? And there is an error h in measuring the value a. So the error in the function f is delta f equals to f of a plus h minus f of a. And the proportional error in this function is simply delta f over f equals to f of a plus h minus f of a divided by f of a. However, in such computations, we conveniently use the approximation to the proportional error, that is df over f equals to f prime of a times h over f of a. So the approximate percentage error is then found by multiplying 100. Okay. For example, class, the radius of a sphere is found by measurement to be 3 cm. But there is possible error of positive negative 0.03 cm. So ito yung possible error natin. And then, or error in measurement. Tapos, yung measured value niya class is 3 cm. Find approximately the error and percentage of the value of the surface area of the sphere that might occur because of the error in the radius. So the surface area S is given by the formula S is equal to 4 pi r squared. Okay, so this is the formula for the surface area ng sphere natin. And for r equals to 3, okay, yung radius niya is 3, the area is magiging 36 pi centimeter square, diba? If we substitute 3 here, so 3 squared is 9. 9 times 4 is 36. Okay. Centimeter square. The error is approximated by ds or differentiate of S or the surface area S is equal to S prime of R, okay, times H. Okay. S prime of R times H. So, ang derivative ni S, ito yung function natin. Ang derivative nito is 4 times 2 is 8 times R is 8R pi. Si pi is constant yan. And then H times H. So that's why naging 8 pi R H. The quantity H is equal to plus minus 0.03. Ito yung error or possible error. And so the approximate error class is ds equals to 8 pi. Replace R by 3 and then replace H by plus or minus 0.03. So the approximate error is positive negative 0.72 pi centimeter squared, and then the approximate proportional error is, okay, ito yung pinapahanap. Approximate proportional error is ds over s sa formula sa previous slide plus or minus yung 0.72 yung ds natin. Okay, yung result ni ds. And then, yung s natin is 36 pi. Diba, ang surface area natin is 36 man. Kasi 4 times 3 squared. Okay, 36 times pi is 36 pi. So, this is equal to 0.02. Ito, yung equivalent niya, si s naman is yan. And the approximate percentage error is positive negative 2%. Nag-times lang tayo dito ng 100%. Okay, so formula lang din. Next is the differential notation. So, ito yung mga notations na kailangan natin i-familiarize. Kasi usually sa ibang books na iba yung ginagamit na notation sa differentiation or derivative. Now, we have dy equals to f prime of x dx and arrive at the expression dy over dx, okay, so divided process by dx lang, is equal to f prime of x. So, pag nakita ninyo yung expression na to, dy over dx, ibig sabihin na to is derivative lang yan. First derivative ni function y with respect to x, or that is just equal to f prime of x. This notation is employed by Leibniz in his pioneering works in the calculus in late 1600 and still widely used as of today in mathematics and applied sciences. This is just another symbol for the derivative of y equals to f of x. Yun nga yung sinabi ko kanina. Pag nakita nyo yan, derivative lang yung class, first derivative. Let c be a constant and u equals to f of x, b equals to g of x or functions of x, and f prime of x is equal to du over dx, and g prime of x is dv over dx. Both exist. Then the following are rules of differentiation using differential notation. So in this table, okay, so ito lang yung summary ng theorems on differentiation class doon sa module natin sa prelim average. So, pwedeng hindi ko na ito discuss kasi summary lang man ito. Okay, ang ibig sabihin lang nito class, derivative of the constant with respect to x is equal to 0. Or derivative of c, where c is a constant, is equal to 0, diba? Derivative ng constant is always equal to 0. Ito naman, derivative of the function x to the power of n with respect to x is n times x to the power of n minus 1. Pag ganito exponential, baba lang sa exponent, and then minus tayo ng 1. So, ito yung ibig sabihin ng sa pangalawang row. Okay. The same with the second column. Then, dito naman class, derivative of the constant, the function c times u, where c is the constant, is diba ang sabi ko dun sa theorems on, or na-mention ko dun sa theorems on differentiation, pag may constant times exponential function or may variable, after sa number, pwede ilabas muna si constant, saka natin kunin yung derivative ng function natin. Then the same with this, d of derivative of u plus d with respect to x is du over dx plus dv over dx or du plus dv. So ito class equivalent lang talaga yan. Okay? So kung multiplication naman, product rule. Kung division, ibig sabihin quotient rule. Kung eto ganito, chain rule yung gagamitin. U to the power of n is n times u to the power of n minus 1 and du. Okay, so yan yung mga differential notations. Mapapansin ninyo, d over dx or dy over dx or du over dx yung ginamit dito kasi ang inadapt dito is yung kay Leibniz, yung notation ni Leibniz. Okay, so parehas lang talaga doon sa theorems on differentiation. For example, class, given that y equals to x squared plus 2x plus 1 quantity cube, so this is our function here, and x is equal to 3t squared plus 2t minus 1. Okay, so dalawa yung function natin dito. Y at saka y in terms of x and x in terms of t. So find dy over dt. Okay, paano ba natin yan as a solve? So here we have dy over dt natin class is just equal to dy over dx. Saan ko kinuha? Para ma-arrive natin si dy over dt, kukunin natin yung derivative nito. Dy over dx kasi mag-derive tayo dito with respect to in terms of variable y with respect to x. Dito naman, yung dx over dt na yan class, yan yung function natin na x in terms of t. So, kung di ba, ang tawag dito, kung i-simplify natin to dx, kasi makakancel siya, so dy over dt na lang yun. So, ibig sabihin nun, para ma-obtain natin si dy over dt, kailangan natin kunin yung derivative nito, and then yung derivative dito, and then i-multiply natin. So, unahin natin si dy over dx. Ang derivative ni dy over dx is magiging 3 times x squared plus 2x plus 1 quantity squared times si 2x plus 2, yan yung derivative ni x squared plus 2x plus 1. 2 na lang yan kasi 3 minus 1. This is equal to 6 times x plus 1 times x squared plus 2x plus 1 quantity squared. And then also, si function na x with respect to t, ang derivative niya is 3 times 2 is 6t, and then derivative ni 2t is 2, and then derivative ni negative 1 is 0 naman. So, meron na tayong dx over dt. So, ibig sabihin, substitute lang natin sa formula na ito. Therefore, dy over dt class is bring down natin si result ni dy over dx multiplied by the result of dx over dt. So, since y is a function of x, diba? Since y is a function of x and x is a function of t, tama diba? Y is a function of x and then x is a function of t. We see that y is actually a function of t. Tama, right? By replacing x with 3t squared plus 2t minus 1. So, ibig sabihin nun, pwedeng si f dito class, i-replace lang natin siya by 3t squared plus 2t minus 1 because x is a function of t lang naman. Okay. We could simply differentiate y with respect to t. So, if we substitute for x in the above expression for dy over dt, we get, okay, lahat ng variable x dito class, palitan natin yan ng 3t squared plus 2t minus 1. Saan yan galing? Dito yan galing sa given natin. Kasi, x in terms of t lang, x in terms of t or x is a function of t naman. So, pwede. And then, para maging dy over dt, tama yung makuha natin na result na dy over dt or y is a function of t. So, since ang x dito is na-eliminate na sa final result, lahat na t yung dito sa right side. So, this is the, I will leave this one as your exercise. Simplify final solve. Another example class dun sa differential notation, suppose that u and v are functions defined on R and that they satisfy the relation u squared plus 2uv squared plus v cubed minus 6. Minus 6 equals to 0. So find the dv over du. So take differentials both sides. So every time na magdi-derive tayo kay variable u and variable v, mag-a-add tayo ng du or dv. Pag nag-derive kayo sa variable na yon, kasi ibig sabihin nung nag-derive kayo sa variable na yun. Pag hindi kayo nag-derive doon, wag yung dadagdagan ng du or dv. So let's say for example dito sa first term, u squared, ang derivative ni u squared is 2u. So since nag-derive tayo dito, mag-add tayo ng du. Sa second term naman class, kailangan natin ditong i-apply yung product rule. So ang product rule is first times the derivative of the second plus second times the derivative of the first. So let's say ang first function natin dito is 2u. We have 2u and then derivative of the second function v squared is 2v. So since nag-derive tayo kay v, mag-add tayo ng dv. Plus the second function na 2v squared, eto siya, and then derivative ni u is 1 times du. So nadagdagan to ng du kasi nag-derive man tayo kay variable u. And then sa third term, v cubed, ang derivative niya is 3v squared dv. Since nag-derive tayo kay v, mag-a-add tayo ng dv. And then derivative of 6 is 0 man and also equals to 0. So 0 minus 0 is 0 pa rin. So if we divide the both sides by du, we obtain dv over du is equal to 2u plus v squared over 4ub plus 3v squared. Okay, so you can verify or solve this one again para malaman ninyo na ito talaga yung result niya. The last topic in this module is the derivative as a rate of change. So application pa rin ito ng derivative. All quantities encountered in everyday life change with time. So consider the following examples. The applicant of a certain job wishes to know her rate or salary in pesos per day. Of course, pag aplikante talaga tayo, ang unang itatanong natin is, magkano ba yung salary ko or yung rate ko pesos in a day or per day. And then another example is the manager asking the number of letters his or her secretary can type in every minute or every minute. So, ibig sabihin, may time talaga. Every time na yung mga daily routine natin is change with time. Okay. A chemist who is interested to know the rate at which a certain substance dissolves in water. Another example is an electrical engineer who wishes to know the rate of change of current in part of an electrical circuit. Okay. A last example class is a biologist may be studying the rate at which the bacteria in a culture are increasing or decreasing. So always, my rate of change. Okay. The average rate of change of W equals to G of T in the interval T and T plus H is G of T plus H minus G of T divided by H. And the rate of change naman, ito is average rate of change. Average rate of change. This one is rate of change of W with respect to time t. So dW over dt. Rate of change man with respect to time t. So G prime of t is equal to the limit of G of t plus h minus G of t over h as h approaches 0. For example, a scientist finds that if a certain substance is heated, the Celsius temperature after t minutes, where t is between the interval 0 and 5, 0 to 5, is given by the formula C of t equals to 30t plus 6 times the square root of t plus 8. So, ito yung given formula natin. C in terms of T or Celsius temperature in terms of T. So find the average rate of change of the Celsius temperature C of T during the time interval 4 and 4.41. Okay, so ibig sabihin nun, si 4 yan yung T T natin. Then 4.41 is yan yung T plus H. Okay, ang hahanapin natin dito is the average rate of change. So, ang gagamitin natin na formula is yung sa first na nabanggit dun sa first slide, yung sa first definition. And then, find the rate of change of the Celsius temperature C of T at T equals to 4. So, rate of change yung pangalawa. So, yung next din na, or second formula din na na-mention sa previous slide, yung gagamitin natin. So, using the definition 5.13, with the time interval 4 and 4.31, we have W is equal to C of T plus H minus C of T over H. So, replace natin si T by 4 plus 4.41 si H. Okay, C of 4 divided by 4.41. So, solving for C of T plus H. So, substitute natin si 4 plus 4.41 is 8.41, right? So, i-substitute natin to doon sa original function natin. So, ibig sabihin lang nito, replace T by 8.41 and then 6 times the square root of 8.41, replace T also by 8.41 plus 8. So, we have 263.2. And then also solve for C of T, where ang T natin dito is equal to 4. Okay? From here, or from this given, sa interval natin. So, substitute natin sa original na equation. So, we get 140. Thus, the average rate of change of the Celsius temperature is W is equal to, okay, bring down lang natin. C of 4 plus 4.41 is equal to 263.2 minus 140 over 4.41, which is equal to 27.9. And then, sa next is find the rate of change at T equals to 4. So, kailangan nating rate of change man, ibig sabihin, kailangan nating i-derive yung function natin. So, ang derivative ni function C of T equals to 30T plus 6 square root of T plus 8 is 30 plus 3 over square root of 30 plus 3 over the square root of T. So, ibig sabihin nun, the rate of change of the Celsius temperature at T equals to 4, replace lang natin yung T dito, yung na-derive na pag rate of change. Replace natin yung T by 4. So, we have 63 over 2. Okay, so that is an example of a derivative as a rate of change.